The next strategy we learned about for comparing fractions is how to find common numerators. So in this problem, we started with 10/15 and 5/6, and we saw that we didn't even need to change this fraction. We could turn 5/6 into with a numerator of 10, just like this fraction. Remember, numerator is the top number. And in order to do that, we saw that we could multiply 5 times 2 to get 10. And whatever you do on the top, you have to do on the bottom, or it won't be equal. You have to multiply by a fraction that equals 1 whole. So then 6 times 2 is 12. Then you could compare 10/15 and 10/12. This one's different. Don't get tricked. If the numerators are the same, you compare the size of the pieces. Remember, smaller denominators are bigger pieces. So if you think about it, if you had a graham cracker and you broke it into 15 little pieces, the pieces would be smaller. If you broke it into 12 pieces, the pieces would be slightly bigger. Think about it like having to share a pizza. Would you rather share your pizza with 12 people if you're really hungry, or with 15 people if you're really hungry? So, when you have common numerators, you're looking for the size of the piece. And if the size of the piece is smaller, that's how you know the fraction is larger. It's easy to get tricked by that, so think extra careful when you have common numerators. Okay, I want to solve this problem. Compare these fractions by finding common numerators. Write less than, greater than, or equal to. 7/9 and 5/6. In the previous video, we found common denominators, but we can also solve this using common numerators. How can I make 7 and 5 become the same number? So now I think of multiples of 7 and 5, or even if I could divide them. Well, to think like this problem, I don't think I can turn 7 into 5. And I don't think I can turn 5 into 7. But maybe I can multiply both of them to get the same number. Let's roll our 5s and then our 7s. Okay, 5s are easy. 5, 10, 15, 20, 25, 30, 35, 40, 45, and so on. Okay, now let's roll our 7s. 7 times 1 is 7. 7 times 2, 7 times 3, times 4, times 5, times 6, times 7, and so on. Okay, do you see any in common already? I do. Aha, we could multiply both by each other. They both multiply to get 35. So I could turn both of these fractions into 35ths. Let's do that. Or sorry, 35 out of something. So, start with 7/9. I know that I'm going to turn this into 35 somethings, and then 5/6. I know I can change this numerator also into 35. All right, but how do I get there? Well, this actually led us to the next step, because we saw from rolling our 5s and 7s, how do I make 7 become 35? I multiply by 5. And that gives me a clue to my next step, because whatever you do on top, you have to do on the bottom, or it's not equal. We have to multiply by a fraction that equals 1 whole, because any number times 1 equals that number. And then same thing down below. How do I get 5 to be 35? I multiply by 7. 5 times 7 is 35. That gives me my next clue. Whatever you do on the top, you have to do on the bottom, or it won't be equal. We have to keep those proportions the same. So 5 times 7 is 35. 6 times 7 is 42. And then we didn't finish up top. 9 times 5 is 45. Now I can compare. I have 35 45ths and 35 42nds. Now don't get tricked. They both have the same amount, but we have to look at the size of the pieces. So if you're really hungry, would you rather share with 45 people or 42 people? Which are going to make bigger size pieces? Hopefully you said 40 seconds. Oops, let's try that again. It's hard to circle on the computer. So 5 6, 35, 40 seconds is bigger than 7 ninths. So just like we showed in common denominators, we find the same answer with common numerators, just so long as we don't get tricked.